All right, today we're diving into one of the most fundamental ideas in artificial intelligence.
Ever wonder how an AI does that? How it finds its way through a maze or figures out the absolute best route on Google Maps? It kind of feels like magic, doesn't it? But behind the curtain, it's actually a beautifully logical process of just searching. And to really get it, we're going to follow an AI on a very specific mission. So, let's set the scene. Picture this. You're on a trip in Romania, starting in a city called Arad. You need to get to Bucharest, let's say to catch a flight. This simple road trip is the perfect, and I mean perfect example, to understand how an AI actually thinks, how it plans, and how it finds the best possible path. Now, to solve this problem, every good story needs a hero. And in the world of AI, our hero is called a problem-solving agent. It is the brains of this whole operation.
So what exactly is a problem-solving agent? Well, you can think of it as a system that is completely obsessed with a goal. Its entire purpose in life is to figure out a sequence of actions, a plan, that'll get it from its starting point to that finish line. It's like a digital explorer, charting a course through a whole world of possibilities.
And the agent's process is brilliantly simple, really. It's just 3 steps. First, it has to formulate the problem. You know, what's my goal? What are the rules? Second, it has to search through all its options to find a path, which we call the solution. And finally, once it has that solution, it executes the plan. Formulate, search, execute. That is its entire playbook.
Okay, so before our agent can even begin its search, it needs a map. But not just any map. It needs to see the entire universe of what's possible.
This special map is called the state space. The best way to picture it is as a giant web. Every point on that web, a node, is a possible state, like being in a specific city. And the threads connecting those points, those are the actions you can take, like driving from one city to another. The agent's whole job is just to find a path through this massive web.
So this is how the agent translates our real-world road trip into a language it can actually understand. The initial state is simple. I'm an Arad. The available actions are, go to another city. The goal test is a question it asks over and over. Am I in Bucharest yet? And finally, the path cost. Well, that's just the total driving distance. With these rules in place, the agent now has a perfectly defined problem it can work on.
So, our agent is ready to search. It starts with a pretty basic method called a tree search. It's, let's say, determined, but it has one massive critical flaw. It has no memory. It's completely forgetful.
Let's just watch this thing in action. It starts at the root of its search, which is Arad. It expands its options, creating new branches on a tree for each city it can drive to. So from Arad, it could go to Sibiu, Timisoara, or Zirint. Let's say it follows the path to Sibiu. Now from Sibiu, it sees it can continue on to Făgăraș, but it also sees a path that goes right back to Arad.
And because it's a forgetful little explorer, it has no idea it just came from Arad. To the agent, that's just another valid option. So it might actually waste time and energy driving in a circle, from Arad to Sibiu and then right back to Arad again. This is what we call a loopy path, and it's a huge, huge problem.
And this isn't just a small hiccup, it's a deal breaker. As the source material puts it, loops can cause certain algorithms to fail, making otherwise solvable problems unsolvable. I mean, just imagine our agent driving back and forth between 2 cities for all of eternity. It would never get to Bucharest.
So, how do we fix this? Well, the solution is actually really elegant. We give our agent an upgrade. We give it a memory. And this one change transforms our naive tree search into a much smarter graph search.
And here is the core difference. A tree search can just blindly revisit the same places over and over again, getting stuck in those loops. A graph search, though, is way smarter. It keeps a list, it's called an explored set, of every single location it has already visited. It literally has a memory of its own journey.
Okay, so let's replay that same moment, but with our new, smarter agent. It starts in Arad and it moves to Sibiu. But this time, as it leaves Arad, it makes a crucial little note in its memory. Okay, I've been to Arad. Check.
So now it's in Sibiu, and it's looking at its options. It sees that path leading back to Arad, but before it takes another step, it does something new. It consults its memory, that explored set.
It checks the list, and it sees Arad is already on it.
Recognizing it's already been there, the agent instantly just discards that path. It refuses to go backward. And just like that, no loop, no wasted time. The entire search is now focused only on new, unexplored paths forward.
Now, this might seem like a really small change, right? Just adding a simple list. But this one upgrade, this memory, is what allows AI to go from solving our little road trip to tackling problems on an absolutely astronomical scale.
I mean, take the 24 puzzle. That's a 5x5 version of that little sliding tile game. The number of possible configurations is around 10 to the power of 25. That's 10 septillion configurations. A forgetful tree search would get lost in loops almost instantly. It would be infinitely impossible. But a graph search, with its memory, can actually solve it.
And this same principle, it powers so much of the world around us. From a robot navigating a warehouse to designing the complex layout of a computer chip, from planning the most efficient route for a delivery truck to how search engines literally crawl the entire internet. All of these depend on this smart search that avoids getting lost in loops.
So here's the crucial point, the main takeaway. Intelligence, in this context, isn't some kind of unknowable magic. It's a systematic process with a simple but incredibly powerful trick. The ability to remember where you've been, to learn from your own path, is what turns a problem that seems impossible into one that's totally solvable.
And that leaves us with a fascinating thought. If the key to solving a problem with 10 septillion possibilities is to simply remember your steps and not repeat your mistakes, what does that imply for us? What complex, looping problems in science, in society, or maybe even in our own lives are we just one simple memory away from solving? Thanks for joining us for The Explain.